Hi, Edbook worms. This is Saebelo, and today we will be doing Physical Sciences Grade 12. The section that we will be covering is on work, energy, and power. Particularly, we will be covering the first part, which is work, work, work. So, what is work? If we just take time to consider the everyday use of the term work, what is work? Well, if we take a look into the Oxford English Dictionary, they define work as a set of tasks, or rather a task or set of tasks that need to be performed. Now, if we consider our mom and dad, our brothers and sisters and uncles, when they say they are going to work, then they are most probably going to perform some tasks of which they will be remunerated for. Now, as you know, as scientists, we shy away from everyday thinking, from normal thinking. We think in a world of our own, okay? So, what is work in physical terms? If we take a look into mechanics and you start to consider, what is work? Well, work is defined as follows. If you have a certain force being exerted on an object, and this object undergoes displacement, then we say that the work has been done. Okay? We have a force being exerted on an object, and this object undergoes a certain displacement. Then work has been done, just as I have demonstrated. And this fact is also reinforced by Newton's second law, which states that if you apply a certain force on a mass, the object will accelerate in the direction of the force. So, as we move along, we've moved past our definition of work, saying that if we apply a certain force, then the object must undergo a certain displacement. Now, we represent this in the equation, or rather using the equation, W is equal to F delta X. Now, if you take a look at the equation, it states what I've just said. Your F is your force, your delta X is a change in displacement. So that's just your product of your force and displacement. Moving along, as we know that in physics, we normally deal with physical quantities, and we classify them as either vectors or scalars. Now, from our past work in grade 11, grade 10, we know that a vector is a physical quantity that has magnitude and some direction. Now, scalar is just a physical quantity that has only magnitude. So, work is also a scalar. So, when you do your calculations for work, you do not indicate direction. Now, if we should take an example using the definition that we've used and our basic equation, let's say we have my hand over here applying a force of 3 newtons on this block over a distance of 2 meters. Now, you have your 3 newtons and 2 meters, multiply that, and that gives you 6 joules. Now, joules is a unit of measure for work. Work is measured in joules. And this is also equivalent to a Newton meter, as you now probably see in your screen. A force is a vector, and a vector has direction. So you might find that a force might not be acting in a straight line. It might be acting in some various directions. Okay? So, the first case we look at, let's expand this equation into its full form. W is equal to F delta X cos some angle theta. Now, this angle theta is very useful, and you will see now as I move on to explain why we use F cos theta. Now, the first part, we can use the example of my hand exerting a force on the object. Now, my hand is exerting a force that is parallel to and in the same direction as the displacement of the object. So, what does this mean? The force is parallel and in the same direction as the displacement. So, the angle between the force and the displacement is 0. What does that tell us? For forces that are acting parallel and in the direction of the displacement, the angle that we use in this cos element is 0. Now, we then proceed forward. We move on to some certain angles. For example, let's take 90 degrees. Here I am. You can also picture a waiter in the restaurant walking around holding a tray in his hand. And as I move my hand, I am moving my hand in a horizontal direction. Okay? So let's consider gravity. Gravity is acting in that direction. Would you say that gravity is doing work on this object? Certainly not. Why? Because gravity is acting in that direction, whereas the displacement is in the horizontal direction. So what do we say? Forces that are perpendicular to the displacement of an object do no work. We spoke about forces that are parallel and in the direction of the displacement of the object. We have spoken about forces that are perpendicular to the motion or rather displacement of an object. Now, let's talk about a specific type of angle that applies to a specific type of a force. So, consider that you are pushing an object across a rough surface. Now, the moment I say rough surface, you already know that there's a certain extent of friction that is being exerted along the object's surface. So, this now tells us that we have friction that's acting in the direction opposite to the motion or rather displacement of the object. Now, if you look at the angle between the displacement, the direction of the displacement of the object and the direction of friction, that gives us a total angle of 180 degrees. Now, if you go back to parallel forces in the same direction, we said we use cos of 0, which gives us 1. Now we have parallel forces but in opposite direction, and now we use cos of 180, and we already know that cos of 180 is minus 1. Now, what is this cos of theta? Well, if we re-unpack this equation, we find that the equation is actually W is equal to F cos of theta delta x. Now, from your grade 11 work, F cos theta should already tell you that we are working with the x component of the force at a certain angle. I hope that this has been informative. I'll see you in the next video. Thank you.